Hi everybody and welcome to AP Macroeconomics with Mr. Farmer. Today we're talking about the GDP multiplier effect. So beforehand we talked about the investment demand curve, so just a review about how it shifts. If there's changes in cost to acquire the equipment, that can change because again we're talking about how much did you invest or how much interest rate are you paying on the investment demand curve versus how much money do you want to invest. And that can shift around. You're more willing or less willing to invest money at certain percentages. You'd compare that to the return on investment or ROI. And so it changes to cost to acquire it, business taxes, tech change, stock of goods on hand expectations. All those things can change around. So as we go through spending and investing and all that, we want this curve in the back of our heads. So macro is all about the domino effect. What I mean by that, and what are we talking about for this instance? It means when one thing gets started, it can grow into a bigger and bigger thing, whatever that thing might be. So again, the idea behind this for today is the idea that money is used over and over and over again. What I mean by that is the same physical dollar might be reused. I go and spend it at store A. Store owner of A goes and spends it at company B. Owner of company B takes that and it keeps going on. So you have this ripple effect. And what we are going to be focusing on is that MPC and MPS, marginal propensity to consume and save. So when there's an out of the ordinary change to spending, you get that bonus, you find $10 on the ground, all of a sudden this domino effect, the ripple grows in a way we aren't expecting this. And so we're going to talk about how large that change in income will eventually be. So the multiplier effect, and this is the GDP multiplier effect. Later, when we talk about finance, we'll talk about the monetary multiplier. So GDP increases or decreases directly with spending. It makes sense because spending kind of helps determine the GDP. So the more spending, the higher real GDP, the less spending, lower real GDP. However, changes in real GDP are greater than the initial spending. So if businesses all of a sudden spend more money out of the ordinary, that's going to have that ripple effect, that domino effect, and that's what we're talking about today. And what the government might do with this is, hey, if we have a GDP gap, negative or positive, and we're trying to get that going, do we need to fill in that entire gap, or can we get the ball going down the hill and it'll pick up speed? And maybe that's a reason why we start talking about government spending and fiscal policies or those things, which is going to be in the next chapter actually. So the multiplier determines how much larger that change will be. And so the multiplier, by definition or by equation, is the change in real GDP divided by the initial change in spending. So it does give you the change in spending. So by rearranging this, we can identify that the change in real GDP, which is usually what we're trying to figure out, is the multiplier, which is usually M, times the initial change in spending. Okay, so we're going to want to know this equation. And so usually the shorthand is, again, just M times change in spending. And that's going to help us figure out how large of the change in real GDP it's going to be. So if investment in an economy rises by 30 billion and there was a real GDP increase by 90 billion, what do you think the multiplier is? Just take a second, see what you think it is. It's 3. 90 divided by 3, the real GDP was 90, and the 30 was the initial, so you get 3. There you go, so the multiplier is 3. A couple things to note, the initial spending is usually through the investment spending. If you guys remember in chapter 7, we talked about usually the growth for an economy does come from businesses, and so this is also one of the reasons why it's focused on that way. It's just where most of the changes to spending can occur. If you think back to the investment demand curve, who is most likely to have an investment opportunity? Yes, households can, but typically is businesses who have the ability to invest, which would be a change out of the ordinary. And since we're talking about the change, it usually is businesses. Again, households and government can also spend, can change that, but it tends to be pretty consistent actually. The initial change in spending, it results from a change in real interest rates. Okay, going back to that investment demand curve, or shifts of the investment demand curve in general. So the real interest rates, and that could be where the Federal Reserve Bank or the central bank of the country can come into play. So we'll come back to this actually, or just those the investment demand curve shifts that can happen in other ways also. And then 3 is the multiplier may be positive or negative. It's going to be negative almost exclusively with the tax multiplier, and I'll give you that to you at the very end. Otherwise, it's usually positive, but you can have a positive increase or negative change to the spending, either an increase or decrease to the spending. So that's usually how you get these increases or decrease numbers, though. So what's the impact of the MPC and MPS on the multiplier? Well, since money is reused in the economy, the amount that it's reused plays a role. So we're going to assume that all the money can be spent will be spent. Now, this is very theoretical. Try going somewhere and spending $10 exactly to the cent. You're probably going to be a couple cents short, and that adds up. So it is going to be, in reality, it's going to be a little bit smaller than the multiplier that we plug into actually says, because we're assuming it can be spent perfectly down to the cent. So you have the increase in investment. There's an out of the ordinary investment. So there's going to be a change in income. They're going to spend $5. The MPC is 0.75. So of those $5, they're going to spend $3.75, and then they're going to save $1.25. So this $3.25, it goes on to that shopkeeper B. And they're going to take this $3.75 and they're going to save 80 or 75% of it. So they're going to save $2.81 and then, or they're going to spend $2.81 and then save 94 cents. The $2.81 then goes to shop person C, and they're going to spend 75% and then save. And we keep going. So this $2.11 keeps going, etc., 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 etc. You can see at the very end we go all other rounds, because we would go through 30 or so rounds. So it started out as just a $5 change to spending, eventually grew to $20. And that does include the initial. You can see total change includes the initial change is $20. That's the multiplier. So what's the equation we can use? Well, the multiplier is 1 over 1 minus MPC, which is the same as saying 1 over MPS. Since MPC plus MPS equals 1, it's the same equation. So for instance, if you have an MPC of 0.5, okay, then that means you have an MPC of 1 over 1 minus 0.5, or 1 over 0.5 is 2. So whatever the initial spending would be, it would be 2. If you're more likely to spend a good chunk of your money, 90%, then 1 divided by 1 minus 9 is 1 over 0.1. Your multiplier is going to be 10, because you're going to spend a lot more of that money. And so we have a larger multiplier. Now, in the United States, the MPC is actually around 98%. So it's actually very close, 98, 99% depending. So it's very high actually. So we will use numbers like 0.75, 0.8, but reality it's actually almost near 100% MPC is what the data shows us. We'll just use simple numbers though. So let's do an example. If the initial change in spending was $10 and MPC is 0.75, what is the total change in GDP? Go ahead and pause for a second and see what you come up with. So first stage is we get the multiplier, 1 over 1 minus MPC, which is going to equal 4. That's our multiplier. So then we told you the initial change in spending was 10. So 4 multiplier times the initial change in spending equals, there'll be a $40 change to the GDP, and yes, that does include the original $10. So how about for tax? Instead of new coming in, what if money was being taken out, say via taxes? The multiplier equation is going to be the MPC times 1 over 1 minus MPC, or another way of saying that is MPC times 1 over MPS. Now, if we kind of simplify this a little bit, we just go with MPC over MPS. So this is going to be the tax multiplier equation right here. Now, you notice I put a negative on there. Here's the reason why. As you can see here, I usually do add a negative to the equation to help remember that taxes deduct the money. Now, why do we do the MPC at first? Because it's assumed that if I have $100 tax, was I going to spend all that originally? Okay, was I going to spend all that money? No, I would have only spent some amount, whatever the MPC was. And this part is the only part that would actually affect the economy. So this part is why we multiply by the MPC. Let's say this is a 80% MPC. So out of this $100 tax, I would have only spent $80. And then that would have been carried on through the multiplier. So we do the MPC first to talk about how much would actually have impacted. And then I take this away. And now this is kind of the funny part. The reason why I do the deduction is this is money that domino won't get tipped at first. It's the absence of this happening, whereas the expectation is it would have happened. So this is what I would have done for the tax. So let's say you have a tax worth of $100 and MPC of 0.8. Same example I was just doing, but just so we can see this all the way down. So out of the $100 taken out of your income, you would have spent $80. Thus the first part of the equation. Why multiply by the MPC? So then we take that amount, the $80, and use that for the rest. So the equation is the tax amount times the multiplier. So the tax amount is $100. So we do negative 0.8, the MPC, times 1 over MPS. And again, we can just simplify again, we're doing the change in tax times negative MPC, that would be the 0.8, divided by MPS, that would be the 0.2. And so this turns into -4. So 100 times -4 means $400 decrease to the GDP because of the increase in taxes. $400 will be taken out of the economy. So how large is the multiplier really? It's smaller than what the equation says. Why? Because the multiplier is based on a simplified model. The idea that the MPC doesn't change from round to round and that everybody's MPC is also identical is a bit absurd. It's not the same between you and me and whoever else it is. There's going to be slight differences. And it's also based on the concept that all money can be spent. But again, try spending a $1 bill exactly at a store. And the rule is for the multiplier, it goes down to the fractions of the cents to be spent also. It's just not doable. So you can see the MPC from 1990 to 2001 is, you can see the MPC 92, 92.9, 93.9, 99, 98. Okay, it doesn't stay consistent year to year by any means. Other issues, as taxes increases, the MPC is going to decrease. It only looks at how much of the tax would have been spent. The saving portion may have been spent eventually, or it might have been different for that tax portion. Well, if you buy imported goods, then that money goes out of the country and then that doesn't keep continuing on. So again, it's a ballpark figure because there would also be people coming from outside of that country and buying, and now there's a start of a cycle of domino effect going on. It doesn't account for inflation, but you can see we're going to be looking at that one later. So what are the takeaways? So again, we had to kind of go back over the investment demand curve because that does help us identify why there's changes in spending. We talked about this thing called the multiplier effect and what the multiplier was in general. Also talked about why it might be used, for instance, by the government, for instance, for the GDP gaps, and also the issues with the multiplier concept. All right, hope that helped. Till next time.